Number 1 says select all quadrilaterals for which the diagonal is, or for which a diagonal, so at least one diagonal, is also a line of symmetry. So for a trapezoid, that would not be true. Isosceles trapezoid would not be true either. Parallelogram, just a parallelogram that's not any of these other things, that would be no, the diagonal is not going to be a line of symmetry. A rhombus would, so we'd have each of these side lengths being the same, and each of the diagonals actually would be a line of symmetry, so this one's good. A rectangle would be false. A diagonal is not a line of symmetry. And then a square would have the diagonals being lines of symmetry. Number 2, show that diagonal EG is a line of symmetry for this rhombus. So we want to show that this is the line of symmetry, meaning that these two triangles would be congruent. Now they told us that it's a rhombus, so we know that all 4 sides are congruent, since that's the definition of a rhombus. So we can start typing out our proof here. So since EFGH is a rhombus, we know HE is equal to EF is equal to HG is equal to FG. Then they share that orange segment in the middle. So we also know that EG is equal to EG because it is the same segment in both triangles. Then that gives us that the two triangles are the same. So then by side, 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 we know that triangle GHE is congruent to triangle GFE. And we can mark that middle segment as congruent on there. And therefore, EG is a line of symmetry of EFGH. Number 3, ABDE is an isosceles trapezoid. Priya makes a claim that triangle AEB is congruent to triangle DBE. Convince her that this is not true. So let's take a look at the 2 triangles that she stated. So she stated that AEB is congruent to triangle DBE. So let's convince her that this is not true. And you have multiple different ways that you can convince her. So if your explanation isn't exactly like mine, that doesn't mean that it's wrong. But if 2 triangles are congruent, then their corresponding sides and angles must be congruent. And in this case, so angle, she has side AE and DB marked or like together in the statement, and those are congruent, so that's not going to help us. EB and BE are the same as well. And then AB, so the first and last, so side AB and DE should be the same, and they aren't, so you could talk about that. You could also look at the fact that angle A is first in this orange triangle and angle D is first in this blue triangle, and those are not the same. And that's the one I looked at. So angle A and angle D are corresponding in Priya's statement, but they are not congruent. Therefore, the triangles themselves are not congruent. Number 4, in quadrilateral ABCD, triangle ADC is congruent to CBA. So they're giving us that these two triangles are congruent, and then we need to show that it's a parallelogram. So remember that in order to show that something is a parallelogram, you need to show that the opposite sides are parallel. So we're going to need to show that AB is parallel to DC, and then also that AD is parallel to BC. And remember, we can prove that lines are parallel by corresponding angles being congruent or alternate interior angles being congruent. And in this case, since we've got this diagonal through the center here, or since we've got a diagonal, we're going to be looking at talking about alternate interior angles. So we're going to see alternate interior angles there that we need to prove are congruent for the blue lines. And then if we look at this orange set, then we're looking at proving that this angle is congruent to this angle. Then we would have those two sides parallel. And the way that we know that those sets of angles are congruent are from them telling us that the triangles are congruent. So so we are given that triangle ABC is congruent to triangle CBA. So we know that angle BAC, that top blue one, is congruent to DCA because they are corresponding parts of congruent triangles. Angle BAC and CDA are alternate interior angles. So we know that AB is parallel to CD. By a similar argument, we could conclude that AD is parallel to BC since DAC and BCA are congruent angles that are also alternate interior. And I don't think you need to write all that. You can just say by a similar, we could prove that those two are parallel, or you could write it all out like we did here. But by a similar argument, we can get these orange ones are congruent, proving that AD is parallel to BC. Therefore, ABCD is a parallelogram since both pairs of opposite sides are parallel. All right, then number 5 says, Priya is convinced that the diagonals of an isosceles trapezoid are congruent. She knows that if she can prove triangles are congruent that include the diagonals, then she will show that the diagonals are also congruent, help her complete this proof. So they want us to draw in auxiliary lines that are diagonals. So we will draw across here and across here. And then we'll just name those in our proof. So draw auxiliary lines that are diagonals, BE and AD. Then AB is congruent to what? So AB is congruent to what? Because they're the same segment. So AB is congruent to BA because they are the same segment. We know angle B, so this angle here, is congruent to what other angle? So that's congruent to this angle, A. So we know angle B and angle A are congruent. We also know that AE, so this side here, is congruent to BD. And therefore, we know that the two triangles, so let me actually draw this one blue. So we've got this blue triangle here is congruent to this orange triangle. And we know that because we see, now we have this marked too, right in there. So we had that side was the same side in both. We had this angle and then we were given that side. So this is by side angle side. So triangle ABE is congruent to BAD because of side, angle, side. So finally, then we would know that diagonal BE is congruent to AD because they are corresponding parts of congruent triangles. Number 6, is triangle AFE congruent to triangle ADE? Explain your reasoning. So they've marked on the picture what they're giving us. They're telling us that this side is congruent to this side, and then that this angle is congruent to this angle. So do we have enough information to prove that the triangles are congruent to each other? So the other thing that we know is that segment AE is in both triangles, so we could mark that. And we don't know any other information. They didn't tell us that E is a midpoint. They didn't give us another angle congruent, that this is a bisector. So this is all we know in each triangle, is that we've got this angle congruent to one, this side, and this side. So we have two sides and the non-included angle. So there isn't enough information here. So there isn't enough information to conclude that the triangles are congruent because we only have two pairs of sides and a non-included angle. All right, then number 7, triangle DAC is isosceles with sides AD and AC congruent. So AD and AC are congruent. Which additional information is sufficient to show that triangle DBC is isosceles? So we want to be able to prove that this one is isosceles. So let's take a look. So if we knew that segment DB was congruent to BC, would that make this orange triangle isosceles? And it certainly would. It has two sides that are equal in length, so by definition that would be isosceles. If we knew that segment AB was congruent to BD, would that prove that this orange triangle is isosceles? And so that would actually just give us that this triangle is isosceles, which isn't what we're trying to prove. So that is not helpful. Angle ABD is congruent to angle ABC. So knowing that doesn't help us because we do know this side. And so if we could prove these two triangles were congruent, then these would be congruent since they're corresponding sides of these two triangles. But knowing this angle just gives us this side, and this angle. So that gives us two sides and the non-included angle. So that doesn't help us prove that those two triangles are congruent. So that's not helpful. Angle ADC, so this angle here is congruent to ACD. So now, I mean, that helps us with this larger triangle. Gives us that the opposite sides are congruent, which they already did. But so that tells us that that bigger triangle is isosceles, not this smaller one. So if they had told us this angle was congruent to this angle, then we would know it's isosceles. But since they did these ones, not helpful. All right, then AB is the angle bisector of DAC. So this bisects this angle. Now that's helpful because now that gives us in each of these triangles, it gives us this information. So now we know that this triangle is congruent to this one. And if those two triangles are congruent, then we know that their corresponding parts are congruent, meaning this is congruent to this. So then we would have an isosceles triangle. All right, then the last one, triangle BDA. So triangle BDA is congruent to triangle BDC. Does that help us? And that is a no. So that would get us, if we knew those two triangles were congruent, I mean, that would give us these pieces are congruent, but that gives us that this triangle is isosceles, not the orange one.